Hi, welcome back to CMG-MathSpace. Step boldly into the math space. Now, continuing with our episodes on operations on sets, we are now dealing with the subtopic of operations on sets on union of two sets. When you say union, you are just combining two or more things together. You and your wife coming together, you and your boyfriend coming together, you and your classmate coming together. Just addition of the what? The substituents. So now the union of two sets, let's say A and B, is a set formed by putting the two sets together. It's as simple as that. In particular, the union of sets A and B is a set of elements that belong to either A or B or both. Now, this is the symbol or representation. A with a U symbol, a symbol looking like a U. B means A union B. Now, the symbol, this U means union. Example, if A has elements of 1, 3, 4, 5, 6, 1, 3, 4, 5, 7, and B has 3, 4, 8, 9, then A union B is 1, 3, 5, 7, 8, 9. We are just adding them. Now, bear in mind, where two or a particular element appears in both, we list it once. Right? So that's what it means. So let's assume, I don't know, how do I put it? I mean, if a number is here, right, and it appears maybe twice here, don't list it twice. Just add the two and list the numbers. It's as simple as that. I hope I'm not confusing you. Maybe I shouldn't have brought this up. So it's as simple as that. Add the two elements, join them in the third set, right? So let's scratch that one. If I see example of that sort, I will draw your attention to that so that I don't get you confused. So it's just a matter of adding both elements in another set. So 1, 3, 4, 5, 7, and then you continue to 1, 3, good. So this is what I was talking about. So now you see 1, 3, 4, 5, 7. You see 3 here again, 3 here again. You see 4 here, you see 4 here again. So in this set, you don't have to write, because you see 3 here again, you write it 3, 3. Or maybe 4 here, go and write it 4, 4. And then continue in that routine or in that sense. This is what I was talking about. Thank God I've seen the example that I was talking about. So if it appears twice, just list it once. So 3 here, 3 here. What did you do? We wrote only 3. 4 here, 4 here. We wrote only, wait. 4 should have come. I think there's problem somewhere. 4 should have come. So that is it. So even though the book made a mistake. So we are just adding the two elements. So 1, 3, 4, 5, 7. If you see, then continue with the 8, 9. Right? You don't have to repeat them twice. So that is good. So this why we have to be taking such classes. The book is also, there could be an omission or mistake anywhere. So that is it. Thank God I've seen this. Now, note, if a member appears in both sets, it is listed or written once. Thank God. It is here. Now, for the above example, 3 and 4 appeared in both A and B, but they were written once in A union B. Thank God. Note also that members of a set are usually listed or written in ascending order. This another extra point. Smallest members first, and then we do that. So let's see the representation in a Venn diagram. Right? So we see the whole union set. We have A and B. This should be the intersection, but because we are joining all of them together, we just shade the whole region of A and B, affecting the intersection. We can actually separate them, but we are shading all of them. We can separate them, but we are shading all of them, because if we add A and B, we are getting another set, which is the union set here. So it's as simple as that. Right, so let's see if you can do more examples here. Now, we have examples here. Example Q has elements 7, 8, 9, 10, R 5, 6, 7, 8. Then A union R you just start listening to 5, 6, 7. 7 is here. You don't repeat it twice. You have 8 here. You have 8 here. You don't repeat it here twice. So it's as simple as that. That is what we are talking about. Example 2. Now, if x is equal to 3, 2, 3, 5, 7, 11, y 1, 3, 5, 7, 9, 11, the union, you just combine them. It's as simple as that. Now let's see more operations here where we have to think a bit outside the box a bit. So we are saying find A union B if A has elements such that 6 is less than x, x is less than 12, and then B is 4 less than x, and x is also less than 9, where x is an integer. So here in each condition is a by condition. We were introduced to that. If you have forgotten, watch the previous episode, right, where we represent sets, how to represent sets. So here it's as simple as that. Because I've already taught this, I'm not going to worry myself. I'm going to give you the trick here. So 6 less than x, x less than 12 is as what it means is that we are listing the numbers between 6 and 12, right? And then when it comes to B, we are listing the numbers between 4 and 9. It's as simple as that. If you don't understand, watch the previous episode. Before, in fact, if you are new on this channel, don't skip any of the episodes, else you wouldn't enjoy this series. I beg. So that is it. So here, if you are listing them between 6 and 12, it means that we are starting from 7. Why are we starting from 7 but not from 6? Because there's nothing like less than or equal to. There's nothing of this sort. Nothing of this sort, or this thing, nothing of this sort. Less than or equal to, that's when you consider the extreme. But if there's nothing like less than or equal to or greater than or equal to, we just pick it from the next number. So 6 to 12, we start from 7. So 7, 8, 9, 10, 11. 12 is not part because it's not less than or equal to. So it's rather less than. So 12 is omitted. If you go to B, we are listing between 4 and 9. There's no less than or equal to here under any of the operations. So we start from 5, 6, 7, 8. 9 is not part because it's not less than or equal to. It's as simple as that. Now we have the solution here. It's as simple as so. After listing the two, what is the main question? What were we asked to do? We have to find the union. So if you are finding the union, it's just a matter of combining the two sets. So starting from 5, 6, 7, 8, 9, 10, 11, you are done. You can represent it this way if you are very good at that. It's as simple as that. Now let's move on to the last question. That's example 4. If C is equal to A, B, and C, and D equal to D, E, F, then C intersection D is not a member, meaning it's a disjoint set. Right, so now let's continue. If C intersection D is a disjoint set, right? Then the sets C and D are disjoint sets. So what we are talking about is we're only talking about the disjoint set. We have already treated this disjoint set. That was the recent episode. So that's what they mean. So now let's see. A union D. We are just combining A and D. So forget about all whatever they were saying. They were extraneous information, but they were just drawing your attention if only you understood what's a disjoint set and blah blah blah. So now if you are going to list them again, what do you do? We start from A, B, C. A, B, C. Now what do you do? Then we have D, E, F. Because the question was for us to get the union set. So forget all the extraneous info. So you have to be very careful, understand what the question is demanding, then you'll be good to go. So here we come here in the Venn diagram, you have the C. This is how elements are represented in a Venn diagram with the dots as the elements, and it's as simple as that. That's another representation. We could represent them in another form like we saw earlier. So thank you very much for watching. See you soon. Ciao for now.